Crude oil and hydrocarbons. Crude oil is a complex mixture of a vast number of compounds called hydrocarbons are molecules made of hydrogen and carbon atoms only. Crude oil was formed millions of years ago from the remains of ancient biomass, mainly plankton, that settled at the bottom of oceans, where it was buried under mud and subjected to intense heat and pressure over millions of years. It's a finite resource, meaning it's being consumed much faster than it can actually form, and it will eventually run out. In the exam, because crude oil is a mixture and not a pure substance, it does not have a single sharp boiling point. Instead, it boils gradually over a wide range of temperatures as the different chain lengths separate. So crude oil is just nature's massive collection of carbon chains all tangled up together. Alkanes. Alkanes are described as saturated hydrocarbons. The term saturated means that all the carbon atoms are joined together by single covalent bonds, meaning the molecule contains the maximum possible number of hydrogen atoms. The first four alkanes you need to know are methane, 1 carbon, ethane, 2 carbons, propane, 3 carbons, and butane, 4 carbons. They follow the general mathematical formula CnH2n plus 2. As the carbon chain gets longer, the boiling point increases. The liquid becomes thicker and more viscous. It becomes less flammable and it turns darker in colour. In the exam, you must memorize the names and formulae of the first four alkanes: methane, CH4, ethane, C2H6, propane, C3H8, and butane, C4H10. Be prepared to draw their displayed formulae showing every single atom and bond line clearly. Remember the acronym MEPB? Monsters eat pupils' brains. Methane, ethane, propane, butane. Properties and complete combustion. Short-chain hydrocarbons are highly useful because they ignite easily and flow smoothly compared to the thick, long-chain hydrocarbons. Fractional distillation. This is how we separate crude oil into its different sections. The crude oil is heated until it evaporates. Then it's fed into a tall tower called a fractionating column. The column is hot at the bottom and cool at the top. As the vapours rise, they cool down. The long-chain hydrocarbons have high boiling points, so they condense and are collected near the bottom. The short-chain hydrocarbons have low boiling points, so they rise higher up before condensing and are collected near the top. Each collected part is called a fraction, and each fraction contains molecules with a similar number of carbon atoms. In the exam, the key idea is that hydrocarbons are separated by their boiling points, and boiling point depends on the length of the carbon chain. Useful fractions include petrol, kerosene for jet fuel, diesel, and bitumen for road surfaces. When any hydrocarbon is burned with an abundant supply of oxygen, it undergoes complete combustion. The carbon and hydrogen are fully oxidized, meaning the only two products formed are carbon dioxide and water. However, if oxygen is limited, incomplete combustion occurs. This produces toxic carbon monoxide gas, along with unburnt carbon particles released as black soot. In the exam, carbon monoxide is dangerous because it's a toxic, colourless and odourless gas. It binds irreversibly to the hemoglobin in your red blood cells, preventing them from carrying oxygen around the body. Remember the standard word equation: hydrocarbon plus oxygen gives you carbon dioxide plus water. Cracking. Industrial oil refining produces too many long-chain hydrocarbons from crude oil, which are thick and not in high demand. Conversely, there's a massive shortage of short-chain hydrocarbons, like petrol, which are highly sought after. Cracking is a thermal decomposition process used to break these long, less useful molecules down into smaller, more valuable ones. There are two main types: catalytic cracking, which uses a hot catalyst at lower temperatures, and steam cracking, which mixes the hydrocarbons with steam at very high temperatures. Cracking always yields a shorter alkane and at least one alkene, which is a type of unsaturated hydrocarbon used to manufacture plastics and polymers. In the exam, always specify that cracking requires high heat and either a catalyst or high pressure. Importantly, always mention that the process creates alkenes, which are far more reactive than alkanes and turn bromine water from orange to colourless. So cracking simply cracks the long, useless carbon chains in half, much like snapping a long stick into smaller, more useful pieces.